Good evening. My goal tonight is to talk about a topic close to my heart, and that's namely nitrous oxide sedation. And the first module we're going to take a look at is going to be equipment and installations. There have been some questions on Dentaltown about installations and what to be cautious about. And so my goal is to get this onto YouTube where it's available to anybody for that matter that wants to take a look at it. It'll be under Quarnstrom nitrous oxide oxygen install for installation, and it'll be numbered 101. We're going to talk about nitrous equipment and the installation in a dental office. My corporation is presenting this, and I'll be giving the lecture. Who am I? I'm a dentist. I'm a pilot. I live and practice in Seattle, Washington. And if the truth were known, except that it's raining outside, I'd rather be flying this evening. I hold a couple of diplomat statuses, hold 4 fellowships. I was a certified dental consultant. I'm starting my 52nd year as a wet hand or now wet glove dentist. It's my 49th year of presenting CE courses. I've done some 255 nitrous, 118 oral conscious sedation, 127 medical emergency courses, and in total about 746 CE courses, about 3,800 hours of presentations in 12 states, 29 states, 12 countries, and 6 dental schools. So I've been doing it a while. It is my 52nd year that I'm starting here as a general dentist. After I graduated, I joined the Naval Reserve, thinking the worst that could happen to me was to be on a large ship. As it turns out, I didn't realize the Navy gave dentists to the Marine Corps. And so I was with the Marines at Camp Pendleton. And about a year later, I crossed the beach with an amphibious assault team of Marine battalions and a CB battalion to build the airfield there. Once I left active duty in the Navy, I went to Washington, D.C. and did the first year of an MD anesthesia residency. Some of the things, medical evacuations of wounded that I got involved in Vietnam, left me feeling a little bit needing when it came to emergency procedures, not realizing that they just never did happen in a general dental office. So after my year of anesthesia residency, I did general anesthesia in my office for about 5 years. It was a stressful situation trying to keep a patient alive and do their dentistry. So I stopped doing GA and for the next 20 years did IV sedation, bordering on general anesthesia. The patients were conscious, but they were fairly deep. And after 25 years of that, I decided it was less stressful if I went to oral conscious sedation, and I started doing that and I've had really good success. I kept track of the first 400 patients. Out of 400, there were 4 people I couldn't treat that I sent out to the University of Washington Dental School for general anesthesia. Much less stressful, and it worked well. I've used nitrous oxide oxygen sedation for the last 48 years, really now probably 50 years since I got back and got into general practice. Just some photos here. Here I am going out through the rice paddies in Vietnam to treat villagers. The villagers didn't have any dentists. The closest dentist was Da Nang, which was about 60, 70 miles from the villages there at Chu Lai. Got involved in medical evacuation of some wounded Marines one night, which was really eye-opening. And we had a little honey bear parachuted to us as a mascot. And the bear got abscessed teeth because we fed him things he liked, like cookies and candy. And it was my first case of general anesthesia. Open drop ether, and fortunately the bear survived, and he appeared to be as smart when he woke up as he had been when he went to sleep. So it was a bit of an adventure for that year. Some people have asked me if you can get CE credits for watching the presentation. It is the same presentation that I've presented many times to various dental school CE programs and dental associations. You need to realize that this recording is being done in May of 2016. Things do change. Discoveries are made, new research comes out. This presentation might not be valid next month, but it is at this moment. And remember, I'm a general dentist, and my emphasis is going to be on information needed by general dentists who are interested in using nitrous oxide. Now, whether or not your board will accept it is a whole different issue. You should check with your board. I've checked with a few of the local boards here in the Pacific Northwest. Washington will accept up to 7 hours of CE online. I think we have to have 32 hours a year, so at least takes care of part of it. Oregon will accept ours, but only if there's a test or quiz that went along with it and a certificate of completing the quiz. So I have written up a quiz that should work for Oregon, and we'll talk about how you can get it here in a few minutes. Idaho accepts online courses, period. So to prove you paid attention while watching the presentation, I have a quiz that I will email you. And if you find you can't pick up an answer, just watch the video again and you'll get it the second time around. To get the test, you need to email me at fredq@comcast.net. I will email back the test, complete the test, and send it with $30 to seconddentalopinion.com LLC, 5767 South Oaklawn Place, Seattle, Washington 98118. I'll grade the test and return it with a certificate of completion. If you have any questions, again, my email address is fredq@comcast.net. So let's talk about nitrous oxide, and I just managed to get a few slides ahead of me. Oxygen, sedation. Sedation early on was probably first practiced in China in the opium dens that were available. People went there and they smoked opium mixtures and got euphoria. Professor Colton in the early years went around the country. This was long before TV, and he would whip up a batch of nitrous oxide and let people inhale it. And of course, this cartoon shows flatulence. There's a lot of giggling about that. It really doesn't happen. But Morton was there and watched a fellow fall and lacerate his shin, but he was not having any pain. In those days, dentists were known for how rapidly they could extract teeth. And he thought, hey, that could be good for my dental practice. And he started using nitrous oxide in his dental practice. Wells, I should say, not Morton. So first of all, we're going to look at equipment that's necessary and lead up into the installations in our dental office. I joke that this was my first office. I'm old, but not quite that old. A young woman is in the chair. Down here we have a portable nitrous tank with little bottles and a couple of reservoir bags. In the bad old days, you held a mask up and you got 100% nitrous oxide, and if you went to sleep, your hand fell down and you would then breathe room air. I like this arm with the belt that drove the handpiece. When I started dentistry, I had just such a contraption, and I was doing a prophy one day on a fellow who had a really bad fitting toupee. In fact, it really didn't fool anybody. It looked a bit like he had a cat on his head, and I caught a little wisp of the hair of that toupee in this belt, and it took 3 trips through the pulleys before I could get my leg, or my foot rather, off the foot pedal. I thought my practice career was over. They really hadn't covered that in dental school. Should I try to put the toupee back in place? Should I walk out of the room and leave him to place it? My dental assistant was not of much help because she went racing out of the room giggling. Be thankful that we no longer have the belt-driven handpieces. So when we get to office systems, this is what they look like. Typically, we have 2 tanks of oxygen. These are symbols for the regulators. A full tank of oxygen typically is about 2,200 pounds. After the gas goes through the regulator, it's normally put into the line at 50 or 55 pounds per square inch. It depends on the machines you're using. There is a switchover valve here so that you'll feed off of one tank until it's empty. When it's empty, then the second tank of oxygen feeds the lines. Down here, we've got a tank of nitrous oxide with a similar regulator, and again, the line pressure 50 to 55 pounds per square inch. There is a fail-safe valve here that will not let nitrous into the line unless you have pressurized the oxygen line. And typically there's some sort of an alarm. In the early days we had whistles. If you don't have oxygen pressure, the whistle goes off. In the walls of the office, there's piping. Now the nitrous and the oxygen piping are two different sizes, eventually going to quick disconnects in the operating areas so that we can plug our machines in. The National Fire Protection Association, FPA, which I served on their gas committee for about 4 years, have classified installations with anesthesia gases as hospital or level 1, where the patient's at grave risk of morbidity or mortality if there's a system failure. So in that situation, you will have backup systems so that if the power went out, you'd have a generator or batteries to keep it going until the surgery was done. Level 2 or day surgery systems, the patient's at risk of morbidity and mortality if there's a system failure. And so they too have some redundancy that adds $15,000 to $20,000 to the cost over the typical dental office. And class 3 or dental office, the patient is at no risk of morbidity or mortality if there's a system failure. And that happened to me one day. We had an earthquake about 50 miles from where I lived in Olympia, and I was in the middle of prepping a tooth, and all of a sudden the lights went out. The patient was on nitrous. All I had to do was take the mask off, let her breathe room air, and within a couple of minutes she's capable of leaving the office. So for us, we don't have to have the high level of redundancy that the level 1 and level 2 systems do. Our gas sources, which we've talked a bit about, typically are either E tanks, the size you see here, or G or H tanks. The H tanks are a little bigger. I'm sorry, the H tanks are a little bit smaller. Typically, this tank will weigh empty about 66 pounds. The G tanks around 100 pounds. The E tanks, which are portable tanks, about 15 pounds. And they, of course, the bigger tanks have more gas. So what is the cost of this gas? Some calculations. I just got this data 2 days ago. A small tank of oxygen will cost about $24. A large tank about $57. But notice when you look at the number of liters, there's almost 10 times more gas in a large tank than in the E tank. So from a cost standpoint, it really does make sense to go to the big tanks. In the case of nitrous oxide, there's about 1,540 liters, or more than twice as much in an E tank. And for the G tank, we're at about 13,000 liters, which is about 2.5 times what you have in the G tank. The nitrous G tank is about $180, and the E tank is about $60. So if we calculate this out and plan on using 2 liters a minute of nitrous and 3 liters a minute of oxygen, that gives us a 40% mixture, which is a high level but not an unusual level of nitrous. Using small tanks, it runs about $11 an hour. Using the large tanks, you're at about $3.50 an hour. Of course, if you have the large tanks, then you need plumbing, and that's an expensive installation. So the gas sources in the US, nitrous comes in blue tanks and oxygen comes in green tanks. In Canada, you'll find your oxygen will be in the white tank, which is the international color. Oftentimes in Canada, the top will be white and the base of the tank will be green. Now, in my travels around the world, I found in Japan, the oxygen was in black tanks. In Germany, we have the nitrous in sort of a gray tank, and the oxygen had a white top on it. And there was a local firm here that was doing some research, and we used it a few times and wrote it up, of Dolinox, which is a 50-50 mixture of nitrous oxide and oxygen in the same tank. It required a much less complex system, basically a simple flow tube and a nasal cannula. This is used in hospital ambulances in some parts of the world, severely injured patients or people with heart problems. Well, we put on this 50-50 mixture, a lot more oxygen than they get in room air, and a fair amount of pain control until they get to the hospital. There are other uses for the gas in the auto industry, uh, and in the hydroplane boating business, and some racing aircraft will have nitrous oxide. The heat of combustion of the nitrous oxide is equivalent to oxygen. The advantage is if you tried to carry a tank of compressed oxygen, you'd carry about a third as much gas as you can with the liquid nitrous oxide. And of course, the other use is to pressurize containers to make whipped cream. These little cylinders are known as whippets. They're about 3 inches long, and the drug gang have been known to try to buy these and release the gas for the high they get from it. Uh, with this, you start out with a canister of heavy whipping cream, and it's pressurized with the nitrous oxide, and then you can pull the handle and you've got your home built whipping cream. It's very convenient for insulin dependent diabetics because you can use artificial sweeteners. So there's a purpose for it. Typically, to buy the whippets, you have to have identification in the store. They don't leave them out on the shelf anymore. So let's take a look at the tank room. This happens to be my office. When we converted the building to a dental office, we built this area behind the office up against the back office wall. And there were a number of requirements. In our case, the fire department in Seattle sets the requirements, and this is something you need to check and see who sets your regulations. It may be the fire department, it may be a plumbing department. It's my understanding Seattle has now gone to the plumbing department, and they'll have specific regulations that if you're going to get it licensed, you're going to have to follow. Some of them were a little bit goofy. It was outside the office, and we had to have steel-clad doors that were fireproof, but they required 72 square inches of ventilation. So you notice the steel doors don't go completely to the floor, and there's another 36 square inches up under the eaves here. In the case that one of these hoses broke, the gas would vent out. The doors had to be self-closing, so they're on a spring loaded. They have to be self-locking, so when the staff is out turning the tanks on in the morning, they've got these doors continually banging into them. There has to be a remote shut-off, and we'll see that in a minute. There had to be a 2-hour firewall between this back wall of the office and the interior of this tank enclosure, which amounted to a couple of layers of drywall, plasterboard. The door had to be locking, it had to be steel. The tanks need to be chained down or some sort of bungee cord so that if there was an earthquake, they won't fall over. And it was required that we put an OSHA signage that would tell the firemen that there was oxygen in this room. That was a great bone of contention. The city wanted me to put a sign stating there was nitrous oxide here. And if we did that, I was sure that the tanks would get stolen on a regular basis. So they finally accepted the symbol, the universal symbol for oxygen. Here's some installations that are bad. If you're going to install inside your office, you're going to have venting to the outside of the office. This was a very simple situation where their shutoffs were these hand-turned valves. That would not fly in Seattle at the moment. You need to have a remote shutoff that can shut off the gas from the front desk. These tanks were simply standing in there. Were there an earthquake and one of these tanks fell over, and particularly the oxygen neck were broken off, you've got 2,200 pounds of pressure in that tank, and it's coming through an orifice that is about a quarter of a square inch. So you would have roughly a 500-pound kick on that 100-pound tank, and it would take off like an Atlas rocket. There was no ventilation in this closet. There was no fireproof door, so that one wouldn't fly now. Here's an office in a small town south of Seattle. They didn't have any way to lock the tanks up. There were no vents. There was no fireproof door. It was outside the office, which is good. And here you see, once the doors were open, the plumber got a little bit artistic here. They didn't have a manifold or a shutoff, but I've seen a lot more wasteful installations. They had 2 tanks of oxygen. By setting the line pressure, say 60 pounds on this one and 55 pounds on this one, this tank would empty first, and then the second tank would empty. This happened to be a logging community, and when you ran out of nitrous, the dental assistant would have to bring this tank out of the enclosure, lift this one down off the step, and replace it. So those were healthy young women that assisted in that office so that they could handle those heavy tanks. Here is a close-up of the inside of my tank room. These solenoids here are shut-off valves, and at the front desk we have a control panel. By pushing a button, they can shut the source of gas off. This manifold equalizes the pressure. So here we see the pressure that we have coming out of our regulators, and here we see the line pressures. You see, on the early days, I'd keep 4 tanks of oxygen, 2 of nitrous. That's not allowed now. It's too many cubic feet. And so we have 2 oxygen and 2 nitrous. We do have bungee cords here holding the tanks to the wall in case there was an earthquake. And once this door is closed, they couldn't fall down. This is of kind of interest. This is a tank of nitrous, but look at the color. It's not that much different than the oxygen tank. It certainly isn't the color of the nitrous oxide. So it's an unstandard color, and it's an unstandard size. The oxygen outlet from the tank is this shape. The nitrous oxide outlet is a very different shape. So you couldn't attach a nitrous regulator to an oxygen tank and vice versa. So we knew this was probably nitrous, even though it was that funky color. And there was a label on it, which was partially torn off, showing that it was nitrous oxide after all, even if the color was not standard. Manifolds for getting gas into the office. My first office outside of the lab, these tanks were secured out there and they were locked, and we could read the line pressure and the gauge pressure to be sure that we had adequate gas every day. When you have 2 gauges, the second gauge tells you the line pressure. The first gauge shows you the tank pressure. If there's only 1 gauge, it shows you the tank pressure, and the line pressure is controlled by taking off this castle nut, and there's an Allen head set screw in there that you can then change the line pressure. This was a more complex system. This could handle 1, 2, 3, 4 tanks of nitrous, and there was a sensor up here that if, 4 tanks of oxygen, if all of the tanks were empty, it had a buzzer at the front desk that went off and a light flash to tell them what gas they were out of. That manifold was just replaced 45 years after it was first put there. You do have to have a way to shut the gas line off from in your office. These are our original solenoids. There are some areas that will require that you have zone valves out in the hallway. Typically, the zone valve would be for the whole office. You wouldn't need one outside each room, and they're costly, right around $1,000 a piece. So if you can avoid them, avoid them. They really aren't necessary. This is necessary so that you can shut the gas off in case there ever was a fire in the office. How does it work? Well, we have a coil here, and when we apply current to that coil, it lifts this ferric rod out of the gas line so that gas can flow. We've got a transformer that lowers the 110 volt current that we have, there's a pilot light that tells us that the gas is flowing, and there's a switch here where we can shut it off. And that's all we had to start with 40 years ago. Now we have something that is much more involved, where we have separate lights for nitrous oxide and oxygen. And the most modern system I have, we have lights that come on for high or low nitrous, high or low oxygen. It tells us if we're on the reserve tank. It's an on-off button. There's a reset if your alarm goes off, and you can push to test. So this really is a nice setup. It works very well. Tank security, there have been instances when tanks were stolen. We had tanks stolen from us. Guy backed a pickup up to our gas enclosure, attached a chain and tore the doors off. Really sort of made me mad, so I started rolling the nitrous tank into the office at night and laying it down on the floor. He was back about 3 weeks later and did it again. That time he stole the oxygen tank. They were probably a little disappointed. There was a situation where a dentist's son went to the office with a number of his friends one night and opened the nitrous tank, filling the gas room, the room where the gases were kept, and the nitrous displaced all the oxygen. The kids were found dead the next morning. So the dentist devised this cap with a lock that prevented the tanks from being turned on. And unfortunately, the valve on the top of some of the tanks were too big, so it didn't work real well, but it was a step in the right direction. Here's a system to lock your tanks so that after the guy tears the doors off your tank room, he can't get the nitrous oxide because they're firmly locked in place. Now let's talk about regulators. We have a bit already. The standard regulator has one gauge here which tells you what the tank pressure is, another gauge here that tells you what the line pressure is, and you can adjust the line pressure with this gauge. On the preset regulators, they're preset at 55 pounds per square inch, but that pressure will vary over a long period of time. And by undoing this castle nut here, you'll find an Allen head set screw in there. And with your Allen head screw, you can change the line pressure, but you do need to have a gauge on this line so you know what you set it at. Again, the primary gauge here tells us the tank pressures. Regulators come in single and two stage. The two stage are very, very accurate. The line pressure doesn't vary plus or minus 1% from a full tank of 2,200 pounds to a nearly empty tank. Single stage regulators vary a bit more, but they're still way more accurate than we need. So what does a regulator do? Well, first of all, here's the line coming from your tank. There's a diaphragm here which changes the needle position, and that registers what the line pressure is. That gas then goes into this chamber, and there's a port here where it can leak through. As it leaks through, it pushes this diaphragm to the right, and that shuts off the port. So in that way, the gas pressure in this line can be set at 55 pounds per square inch. And we've got another diaphragm and gauge here to read that pressure. There is a high pressure relief valve up here so that if this diaphragm leaks, the gas would leak out that vent. And this is a control knob which controls the amount of pressure in the line. And it does that by spring loading this diaphragm. If you want a higher pressure, you crank this in, it pushes the diaphragm to the left and lets a little more gas through. So this is a single stage regulator. Here's a two-stage regulator, which is just basically two of these regulators back to back. There is again a pressure release valve here if you get too much pressure, and this gauge here, or this knob here, changes the line pressure to the 50-55 pounds that you need. It's important to understand the difference between the nitrous oxide and the oxygen. Nitrous oxide under a pressure of 750 pounds liquefies. So a full tank of nitrous will be 7/8 liquid nitrous oxide and about 1/8 gaseous at the top. As you use the gas, the liquid boils off, and here we are. We have a third of a tank left, but our line pressure or our tank pressure has not changed. Here we are now. Once we've used 7/8 of the gas up, we've used all the liquid, and now we start to see the pressure drop. So when you first put your nitrous tank in, you use it for a few days, you check the pressure, and gee, it's still at 750. That's great. I'm not using anything. You just don't see the pressure drop until you've used up all the liquid. Oxygen, on the other hand, cannot be liquefied unless you use high pressure and you get it very, very cold. So in our tanks that we get, it's high pressure, about 2,200 pounds, but it's not high enough to liquefy the gas, or maybe I should say it's not cold enough to liquefy. So it's full of gas under pressure. When you've used half of your tank of oxygen, the pressure now is about half of where it started. So if it started at 2,200, it should be now about 1,100. When you're down to a quarter, it should be, let's back up here, sorry about that. It should be about a quarter of the 2,200, or around 550 pounds when you've got a quarter left. So the pressure is inversely proportional to the amount of gas that's in the oxygen tank. And in that way, you can gauge what the amount of gas is in your oxygen tanks. The slave valve I talked about, when there is oxygen pressure, it pushes a diaphragm down that lets nitrous oxide flow into the lines in your office. And this is a safety feature. You wouldn't want nitrous to flow if you didn't have an adequate source of oxygen. So it's a slave valve or fail-safe. We know of one case where the diaphragm ruptured and the nitrous oxide was able to backflow and fill the oxygen line as well as the nitrous line, and we'll talk about that. And then there's this whistle. When the oxygen line is pressurized, the diaphragm closes this release vent off, and so you don't get the whistle. And there's no question in your mind when you run out of nitrous or oxygen, you have the similar whistles. They're quite shrill. They will gather your attention. As far as tank safety, you always want to have a regulator on the top of your tanks. There was an office that decided they could save some money if they had one regulator that all of the oxygen tanks led to, and that meant that the piping would have 2,200 pounds of oxygen pressure in it, and the Teflon hoses that we would typically use couldn't handle that. What they needed was high pressure copper tubing, and it was stiff and it was hard to regulate and get it attached to the oxygen tank. So the dentist got some high pressure Teflon hose that had a steel reinforcement in it, and in doing so, the hose could handle 2,200 pounds of pressure. But if you turn the tank on rapidly, you get heat of compression. If you ever pumped up a bicycle tire with a hand pump, you know how hot the pump got because of your pressurizing the gas. In this case, when they turned the oxygen tank on, it was able to get the Teflon heated to its ignition point. You now have a fire in a Teflon hose being fed by 100% oxygen, and it blew. It actually got hot enough it blew a hole in the side of the oxygen tank, badly charring the tank room and doing a lot of damage to the office. It's my understanding that a dental assistant died, and the dentist was so badly burned that he couldn't practice after that. And this is the sort of situation you see here, with the copper tubing taking the high pressure gas up to a single regulator. Another tank here with copper tubing to a single regulator. Saved 50, $100 on regulators, but it was a dangerous system, so don't do that. The piping systems have a couple of safety factors, and we'll talk about this. The small tanks have a pin index system, so you shouldn't be able to attach a nitrous tank to an oxygen yoke and vice versa. And the plumb systems in your office have a DIS system, or diameter index safety system. The piping is K or L type pre-cleansed copper tubing that's been silver soldered. You can't go to the junkyard and buy reclaimed copper tubing, because you never know what's been in the copper tubing. So you need to start with new tubing that's pre-cleansed, so there should be no organic materials or anything else in that tubing. And you can't just use the standard solder that you would use if you were building an electronics kit. It has to be silver solder, which is a higher melting solder, so the joints don't give if it's caught if you ever have a fire in your office. You need to have the system done by a certified plumber, and we will talk a bit about a situation where it wasn't. And then you need to check the system to be sure the gases haven't been switched. Your building department or your fire department should also check it. Between the three of you, it should never happen. There was an oral surgery office in Texas, and the dentist, the oral surgeon, had been in practice for some time. He opened a new office, and he told the plumber, who was not certified to do these installations, to go get the manifold out of his old office and solder it into the piping of the new office, save a couple of bucks that way. Unbeknownst to him, the architect and the city had placed the oxygen on the left and the nitrous on the right in the new office, and in the old office it was backwards. So the plumber went, cut the pipes, brought it to the new office, soldered it in, but unbeknownst to him, he's now hooked up the nitrous to the oxygen side and the oxygen to the nitrous side. The first patient he saw, he gave 100% oxygen, he gave 50% nitrous oxide oxygen to start an IV. Once the IV was in place, he gave the patient some Versed and fentanyl to put him to sleep to get his third molars out. He put him on 100% oxygen. That's good. You want to keep the patient well oxygenated. But he saw his pulse oximeter saturation start dropping. It started at 100% oxygen saturation, and within a few minutes it was 95, and then 90, and then 85, and then 80, and he decided that he had some respiratory depression. So he started rescue breathing, bag breathing the patient, and he saw it go to 75, 70. He decided that the patient must have had an allergic reaction, was in bronchial spasm, so he intubated the patient, continued to ventilate him with what he thought was 100% oxygen, and the saturation dropped to 60, 55, 50. The staff asked him if he wanted them to call the paramedics, and he said, no, I've got it under control. He's giving albuterol and epinephrine down the endotracheal tube, trying to break the bronchial spasm, which he didn't have. Eventually, the saturations got down to 40 to 35. The paramedics were called. They came, put the young man on their small tank of oxygen. The saturations went immediately to 100. The young man was 16 years old, an A student, a star athlete, and he woke up with severe vision impairment, a seizure disorder, and a marginal IQ. So you got to be sure that the systems have been checked, and you need to check them also to be sure that you got oxygen in the oxygen lines, nitrous in the nitrous lines. How do you do that? Well, you go out and turn the oxygen tank on, and you go to all your outlets and check to be sure there's gas escaping from the oxygen line and not from the nitrous. Then you shut the oxygen tank off, and you do the same thing with the nitrous, and now you know you got nitrous in the nitrous lines, oxygen in the oxygen lines. When your staff turns these on in the morning, they should go out and they should put their hand on the valve and turn their head. You emphasize with the staff, you don't want any oil on any of this equipment, because when you turn the tanks on, the pressure in the regulator goes from atmospheric pressure, about 14, I think 0.7 pounds per square inch, to 2,200 pounds. And that creates a lot of heat in the regulator piping that attaches to the tank, and it's designed to do that, and the heat dissipates. But if somebody has sprayed a little oil in there so that the regulator doesn't squeak when it's screwed onto the top of the tank, and you turn the gas on quickly, you can reach the ignition point of that hydrocarbon, whatever oil it is, and the regulator can blow up on you. So I always emphasize to the staff, turn the tank on slowly, put your hand on the tank, turn your head, turn it on slowly. If you had somebody lubricate the regulator, and should it blow up, uh, they would be picking pieces of the regulator out of the back of your scalp, but you wouldn't have noticeable scars. You just wear your hair a little longer. And I think they should be turned on every morning. I think they should be shut off every night. When they're turned on in the morning, uh, the staff should look and see what the pressure is so that you're sure you have adequate oxygen for the day. We've already talked about the tank room regulations, but do check it with your fire department. Our installation was checked and certified by the fire department, and about 3 months later, I got a letter stating that I had to shut it off, that it didn't meet code. And I called the fire department and said, all right, you bring your inspector and your attorney. I'll have my installer and my attorney there, and we'll do an OK Corral shootout. Uh, they came, and the fire department inspector looked and said, the tanks are outside in the enclosure. It's locked up. That's everything we need. This system is fine. So, but be sure you check it out. Uh, it is outside, so we didn't have any special requirements. Emphasize again, your tanks have to be tied down. You need a manifold. These older type manifolds just won't cut it in today. And you need shut-off switches so they can be shut off from the front desk. We've seen those slides. We like our new one. Uh, Tank security is very important, and understand that some people do use this. Used to be the hydroplanes that ran on Lake Washington. They'd start down the backstretch, they'd turn on the nitrous oxide because the heat of combustion of 100% nitrous oxide is much higher than the heat of combustion using air. So they get more power out of their engines. The problem is the heat of combustion is much higher, and they had to rebuild engines frequently, but you'd win races. Now we're going to take a look at the small tanks that are typically used with portable tanks. I was doing a course in Salt Lake City, and at about the first half of the morning, we'd usually go do a simple introduction to nitrous oxide. So I've got a room of about 40 dentists and dental assistants, and I've got 4 machines that I set up that morning. And so everybody is to put the patient on 20% nitrous, just begin to get the sensation, and then put them on 100% oxygen and return them to normal. One of the participants came up to me and said, we have a lady back here that's asleep. Well, I move pretty fast when I'm frightened. I go back and I take a look at the lady. She appears to be middle to late 60s. I grab her arm and I get a pulse. So my pulse rate now drops from 180 down to about 140. I gave her hand a little pinch, no response at all. She's out. She's under general anesthesia. I look at the machine. She's on 2 liters of nitrous, 8 liters of oxygen, so it's only a 20% mixture. She shouldn't be asleep. I got my blood pressure cuff. Her blood pressure was quite normal. I give it a minute. She's still asleep. No eyelid reflex if you touch the eyelashes. If the patient's conscious, you'll normally see a little flutter. My IQ is dropping like a rock because I don't know why this woman is unconscious. I'm beginning to think stroke. And here in a minute or two, I'm going to have to call the paramedics. And I had a stroke of genius, and that was take the mask off and get her back on room air. She was okay on room air. Let's go back to room air. So I took the mask off, and she was awake within 30 seconds. And I said, ma'am, how are you doing? Oh, she said, fine, I just had a little nap. Well, she certainly did. She was under general anesthesia because the machine that I had set up that morning, there are normally pins that you see here in the yoke that fit into recesses in the top of the tank. The pins had been pushed out the back of the yoke. God only knows how long they had been gone. So they didn't go into these recesses. And so I had been able to set the nitrous tank on the oxygen side and the oxygen tank on the nitrous side. There is a little washer here that gives you a good seal with the steel tank up against the steel yoke. I've also managed to get a couple of the washers in there, and if you do that, you can back the tank out enough that the steel pins no longer engage the tank. So just because you have a small machine with fail-safe, be aware that I managed to set them up backwards. And so here you see the little pins that were pushed out the back of the yoke. Here you see the tank that should match up with the placement of these pins, which would keep you from hooking a nitrous tank up to the oxygen side. The holes for oxygen are here and here. These are the holes for a nitrous tank. Here's the washer I spoke of, and they oftentimes will stick to the yoke. If you stick a new washer in the tank and then put it in here, you will back that tank out far enough that your pins won't protect you. So those are two ways you can screw up and get the gas in backwards. And as I tell the folks at the courses I teach, if someone as brilliant as me can screw up that badly, what chance do you mere mortals have? But in fact, I'm not the only one that's screwed up. We know of 70 cases, maybe by now 75 cases here in the Pacific Northwest, where gases managed to get switched either from a problem with the yokes and pins or from plumbers that set things up backwards or fail-safe valves that failed. And the moral to the story is the one thing I learned that day is if anyone goes to sleep, take the mask off, get them back on room air. In one of the future programs I'm going to present, it's going to be about the problems with nitrous oxide. And we did some research to show that diffusion hypoxia, which we all learned about in school, which was why we oxygenated people, doesn't exist with what we're doing with nitrous oxide. So it's completely safe to take the mask off. And had the oral surgeon in Texas done that with the young man wouldn't have ended up with all the problems he had. So let's go on. How else can you screw up? Now, this is a case that happened in Oregon. You see the hoses. Here's a green oxygen hose, a blue nitrous hose. The fittings are very different. But in the case of this machine, here is the nitrous fitting. Here is the oxygen fitting, and you see it says oxygen. It says nitrous, but if you unscrewed this fitting from the block and unscrewed that fitting from the block, you could screw them back in reverse order. This machine had a leak in it. It was sent back to the manufacturer to have it repaired. The manufacturer, in the process of rebuilding it, set these up backwards. And so in the clinic, in the dental school, they had a machine that was set backwards. One of the graduate students was using nitrous with his patients for some surgery, had a woman who didn't seem to want to wake up when he put her on 100% oxygen. It went on for a couple of minutes, and he had heard my discussion of what could happen, and that in that situation, if a patient goes to sleep, take the mask off, which he did, and the patient was back within a couple of very short minutes. It seemed like an eternity for him waiting, however. So realize it can happen anytime a machine is repaired, anytime your system is repaired. Check them out and be sure they're right. There are quick disconnects. This was one of the ugliest installations I knew of. The dentist had brought the copper pipes right up the wall, and here's the quick disconnects that went to the machine. In my case, they went down the wall into the crawl space under the office. These outlets were known as Dagmars for obvious reasons, and the quick disconnect went in. This is a much nicer looking installation from the University of Oregon. We had an inspector come to our office and say, well, you can't use that anymore because those pipes are on the surface of the wall, and because you drive cart stretchers and trucks in your office, you could puncture one of those lines. And I explained to him that we didn't use cart stretchers or trucks in the office. Didn't impress him at all. And so we had to have part of the installation redone. The pipes were then inside the wall where they were protected, even though we didn't drive cart stretchers or trucks. This is the device that fits into these connected to your hose. Each outlet will have a different setup, so they need to be matched. So that's we've talked about the pin index system on the small tanks. We've talked about the diameter index system. We've talked that the system needs to be installed by a certified plumber, and there are certification people now that will come to your office and check it out to be sure that everything is correct. And I think that would be a worthwhile money spent. I still wouldn't trust them. I'd check it out myself. We talked a bit about this. How do you check to see if the lines are crossed? Turn on one gas, namely the oxygen. Check all the quick outlets to be sure there's gas flow on the oxygen line and nothing on the nitrous when it's plugged in. You bleed that line by shutting the oxygen off at the tank, partially plugging in one of your quick disconnects. You'll hear the gas escape and it'll calm down as it bleeds off. Then turn on the nitrous, and when you do that, you should hear the alarm, but you check all the nitrous outlets to be sure they're now pressurized, and all the oxygen that they're not pressurized. Now you know it was done correctly. Again, your local building department, maybe fire department, possibly plumbing department, is going to want to look at your plans and look at the installation. The next thing you need to do is check to see if there are any gas leaks in your lines. The easiest way to do this is turn both gases on and then shut them off at the tank. So turn the tank on, you see the line pressure and the tank pressure come up. Take a felt tip marker and mark it on the gauge where the gauge is reading, and then wait 24 hours, and there should be no pressure drop. If there is, it indicates that there's a leak someplace in your system. It could be one of your hoses leading from the regulator to the manifold. It could be, as happened to me in my first installation, there was a bad solder joint that leaked oxygen. In my second installation, I was much smarter. I moved to a new office, we put new lines in, and I did this, and within about 20 minutes, the pressure was going down on the oxygen line. And I went to the gas installer and said, you need to fix this. And he claimed that the carpenters that were remodeling the office had probably driven a nail through the line. And at that point, the general contractor was ready to rip his eyes out. I said, let's don't fight here, but we're going to find that leak. And if the carpenters damaged the line, we'll pay you to repair it. If your guys screwed up and have a bad solder joint, you fix it. Well, it turns out they had a bad solder joint, and they fixed it, and then the second test went well. So check it yourself. We've talked about how you can reverse gases with the small tanks if the pins are missing or if you get too many washers in the yoke, so don't fall into that trap that I did. The other thing you need to be aware of, we oftentimes got wrenches that looked like this to turn our tanks in. The top of the tank has this spline that's shaped like this, and it fits nicely in this hole, and that's how you turn the gas on. If you fit this wrench over the top of the tank, it slips down onto here, and if you were to turn that, you could unscrew the valve out of the tank. This happened in an operating room in the hospital, and when that valve came loose, it went through the ceiling in the operating room, it went through the floor above the operating room and lodged itself in the ceiling of the third floor above the operating room. So if you've got a wrench like this, throw it away. For crying out loud, don't use a crescent wrench. Buy a simple wrench, and the only thing you want is the part that fits on the spline of the tank to turn it on. Now, presently you're required to mark these lines as to which is nitrous and which is oxygen, and there's little stickers you put on, and it has to be marked every time they go through the wall. And I thought that was great. That didn't take much time, But the next thing I knew, the painters are in the office and they get a bunch of overspray while they're spraying the walls in the office, and suddenly those marking stickers were covered with white paint and you couldn't see them. They've solved that problem in that you now have to have different diameters for nitrous and for oxygen. Here we have my office. This is in a control box in the back of the operatory. We've got the nitrous line or the oxygen line coming in. The nitrous line, we have a vacuum line here. We have water lines and compressed gas lines. But let's take a closer look at that. The fittings here and here in the nitrous and oxygen lines are the same diameter as are the fittings here and here. So it would be possible to screw those fittings on backwards, and this is why I strongly advise that you do the check to be sure that you've got only oxygen in the lines going to your machine on the oxygen line and nitrous in the nitrous line. We've talked about what happened here when this machine was sent in to be repaired and the manufacturer reversed them. We do know of one case where the diaphragm ruptured on the slave valve, and so it backfilled the nitrous line. A dental anesthesiologist was giving general anesthesia in this office, and he noticed the patient's saturation start dropping, started at 95, went to 93, went to 90, at which point he shut his machine off from the office nitrous and turned on his small tanks on his portable machine. Saturation went right back up to 95 where it should be. When the case was over, he explained to the owner of the practice that he was pretty sure that they had a problem in their line, and that's what they found. They found that this slave valve system had a leak, and so they were backfilling the nitrous line or the oxygen line with nitrous oxide. We've talked about putting a regulator on the top of each tank. Here's a semi-colored picture of what was left of that dental office. We don't want to go there. Real mess. Now, earlier, about 2 years ago in Spokane, Washington, there was an oral surgery office. One of the staff members came in and noticed a strange noise, and she alerted and got everybody out of the office, and the tank room blew. Something was going on in the tank room, and it ignited the nitrous and something that was combustible. The tank room shouldn't have anything combustible in it, and blew the side out of the building. No one was injured, but consequently, Spokane now has some really bizarre requirements, and that is you got to have a sprinkler system in your dental office if you're using nitrous, because they claim that the patient couldn't self rescue themselves if everybody were killed in an explosion and they suddenly woke up and they're on nitrous. Well, in fact, a person on nitrous is never asleep, and they could get up and walk out of the office, but the building department's not buying it, and they're requiring sprinkler systems in all offices that want to have nitrous oxide. They're having to be retrofit. So here's a picture of the fire that was on the morning news. A staff person heard some popping when she arrived. She saw some white smoke, alerted the rest of the building. When the tanks blew, they blew, but everyone got out okay. Machines come in a variety of sizes. The old flow tube machines was basically a needle valve. As you opened that up, it let more gas flow into the line. There's a tapered tube with a little ball that blows up. This tube is transparent. The higher the flow of gas, the higher the ball is, and that reads off and is calibrated in liters per minute. Same thing with the nitrous side. The two gases then get over here to go to the patient. Machines were required to have an oxygen flush lever so that in the event you needed 100% oxygen, you could push this button. It would shut off the nitrous and the patient would get 100% oxygen. And here you see some of the very early machines. This one was kind of cool. It had little egg-shaped floats rather than round balls. This one actually had etched in it what it did at a certain pressure, 14.7 pounds per square inch, which is normal atmospheric pressure, and at 70 degrees Fahrenheit. So they're very, very accurate. Here you see one of the early Quantiflex that became McKesson machines. They were unique in that this dial turned up the total flow of gas, and then this dial, you could dial in the percentage of oxygen. So you could dial in, I want 70% oxygen, meaning I want 30% nitrous. You would see the nitrous tube here go up to 3, the oxygen tube would go up to 7, and if you turn this down, you could get a maximum flow of 5, and the tubes would adjust. Here was a machine that I had in my office that I really liked, but it read out in percentage of nitrous. So you wouldn't want to have this machine in one room and this machine in another, because this machine is calibrated percentage of oxygen. This one is percentage of nitrous, and it would be too easy to be thinking, oh, I want to give 30% nitrous, so I turn this one, if I wanted to give 30%, I put it on 70%, I go in the next room, oh, I want 30%, so I would have to turn it up to 70% on the oxygen, where in this machine it would be percentage of nitrous. You want uniformity. We did have some machines that came with dials. Didn't tend to be accurate over the long range, but they were kind of slick looking machines. How do the dial machines work? Well, you have the same needle valve. As you open it, the gas flows, and the pressure in the gas line is registered here, and it's calibrated in liters per minute. So you dial up your 2 liters per, or your, let's say 7 liters per minute of oxygen, and then dial up here to get your 3 liters of nitrous, and you know that you're giving 30% nitrous oxide. And they too had an oxygen flush button. Here was one of the early machines that came out of manufacturer loaned me, and they had green lights to show your oxygen was pressurized, your nitrous was pressurized. It was a nice machine. We're now getting percentage mixing machines, and we've seen one in the pictures. They typically have a pressure equalization chamber here, which is a diaphragm, and if your line pressures aren't totally equal, this equalizes it. So the pressure going into the needle valve is the same for nitrous oxide as it is for oxygen. And then as you turn this needle valve, say to 30%, that's 30% nitrous. So this needle valve is almost closed, and this one is much more open to allow 70% oxygen, 30% nitrous. Downstream, you have another needle valve that controls the total flow. So at this point, you have mixed gas at a known percentage, and then this needle valve allows you to control the total flow, which is a really nice type of machine. I like these. And they still have their oxygen flush. So here we see a variety of machines. Here we dialed up the percentage of nitrous. Here we dialed up the percentage of oxygen, and we're now getting computer machines which do this for you. There was a machine at one time that had a demand flow regulator, so that it would give you the flow of gas that the patient needed. There was a rod that was down inside the reservoir bag. When the patient inhaled, this bag would go empty, and that would cause this valve to drop, refilling the bag. As the bag got fat, it got shorter, shutting the gas flow off. And in that way, this machine provided exactly the amount of gas you need. They also developed a demand flow valve. These never really caught on. I don't know of any machines that are now equipped this way. The computer machines are really slick. You have buttons here that you push, which adjusts how much nitrous you're giving, how much oxygen you're giving, and in fact, you can dial up. It reads the percentage. It gives you the total flow. How do they work? Well, the needle valve is controlled by an actuator from the machine, and there's basically a paddle wheel here that senses how much gas is flowing, sends that signal up to the computer. Same thing with the nitrous oxide, and in that way, you get digital readout of your percentage and total flow. And here we see one of those machines. This one is showing the percentage of nitrous oxide in this window, 30%, and the flow rate is 2 liters per minute. You can increase the amount of nitrous oxide or the amount of oxygen. You can change the flow rate here. The machine does have to be plugged in. It takes electricity to do this because it is a computer. And they're really very easy to use, very slick machines, but they are more costly than the standard machines we've talked about. Reservoir bags are necessary because when you take a breath, you'll hit inflows of about 20 liters per minute over about a second. And if you don't have a reservoir bag and you try to get that much gas through a hose, it won't work. The patient will feel like you're strangling them. There are flat bags, which I don't like because if you forget to turn the machine on, there's no gas here for the patient to breathe. If you're going to buy a bag, buy one that's pleated open so they've got a couple of breaths until I remember to turn the nitrous on. We're going to talk more about hoses in the next presentation I put on, but I like the polyethylene hoses. You can buy these the same place the respiratory therapists get them. They were about, came in a 50-foot box, about 50 cents a foot. They last forever, but when they get dirty, you just throw them away and put a new one on. These are endotracheal tube adapters that let you go from the 22 millimeter diameter hosing down to 11 millimeter. And sooner or later, you're going to drop the mask on the floor and you're going to reach for it and step on it and break one of these connectors. When that happens, take a 5cc syringe, cut the barrel out of it, and it turns out that barrel is just the right size to join the mask to the tubing that goes around the patient's head. Unfortunate occurrence in Australia where they had a situation in a hospital where a number of people caught hepatitis B. They decided it was because the machine wasn't being properly sterilized and they required everybody to have a viral filter on their machine. As it turned out, that wasn't the case. There was an anesthesiologist who wasn't sterilizing his endotracheal tubes. And we'll talk a lot about this in the scavenging lecture that I will put up in the next day or two. You need to have manifolds, manometers telling you how much suction you have to get the gas out of the office. We used to have pop-off valves on our masks. We don't any longer. We're going to go through this fairly rapidly. Masks came in a variety of sizes. These big pop-off valves we got rid of. I found that the little pedo mask, if I made the hole opening a little bigger, fit 90% of my patients, and it made a nice small mask that really didn't get much in my way. I did that by cutting 2 millimeters the whole way around and 3.5 here at the top of the mask to fit over the bridge of the nose. And this mask fit almost everybody. Mark them before you cut them with your crown or bridge scissors because you can ruin the mask if you take too much. We now have flavored masks. They come in cherry, orange, a juicy fruit, and a plain Jane non-flavored mask. With kids, sometimes there just isn't room for the mask, and I will get the kids started on a cannula, or if I'm doing apicoectomies, I need access up under the upper lip. You end up putting a lot of nitrous into the operatory, so this is not something you'd want to do on a regular basis. Few people are very claustrophobic with the mask, and so we'll use a cannula to get them relaxed and then go to the regular mask. Here's one of the early scavenging masks, the brown mask, which was a mask within a mask. Very effective. David Donaldson did some research that showed he could get almost 40 parts per million nitrous. Here's the modern one. And the inner mask comes out, can be autoclaved, or you can throw it away and buy a new one. We're going to look at some of the machines. I like this machine, but what happened after a couple of years, these diaphragms that powered the indicators got weak and it became inaccurate. Here's a machine that I really did like. Rather than flow balls, they had little eggs. It was kind of cool. It had a key on the side so you could shut it off so you didn't have to worry about your staff coming in after work. This was a good, inexpensive, simple Advantech machine. Cost about a half of what the rest of them did, and unfortunately it's no longer available. I like the shut off here. It was a simple toggle switch. It really worked well. Some of the machines are flush mounted. This one was kind of interesting. When you turned it on, when you got to 5 liters per minute, then the ball came up in the second tube. Same thing on the oxygen side. They did have a device here that measured the percentage of nitrous that you were giving, but the numbers were really small and pretty hard to read. Their other machine that I still see every so often had a valve off to the side that was marked with the percentage of gas. I had a tendency to bump into that knob that stuck up, and so I tended to unscrew and throw those away. Was a good machine. This is a bad machine. They had the on-off switch and the oxygen flush switch. They're both green. They're both on the same side of the machine. They're a slightly different shape. That's bad engineering. You want them to be very separate. Here's one, the oxygen flush button peeked out from behind the machine. Again, that's bad engineering. It ought to be out front where you can see it. This machine I saw at an ADA meeting, and the manufacturer said, well, you know how our whistle sticks sometimes? I didn't know that. He shouldn't have told me. He said, well, we added a de-sticker valve back here, so if when you turned it on, it would whistle at you, but if that's stuck, you push this button and the whistle would go off. Well, I think they need to fix the on-off valve so the whistle doesn't stick. I did like the name Cloud 9 with nitrous oxide. That's how some people describe. Here was a machine that I was really impressed with. Look at that digital readout. Tell me what percentage I'm using, everything you could want to know. And then he says, and if that doesn't work, you pop the top and here are your flow tubes. Well, that's nice backup. I assumed there was some analysis going on in here. There really wasn't anything. It was being done electrically and it wasn't particularly accurate. This machine, and now you're going back 40 years where no one knew how to read an EKG except a cardiologist. And on the medical shows on TV, if the patient was on the table getting general anesthesia and things were going bad and they were in the process of dying, they would focus in on the reservoir bag, which would fill less and less and less and less. And when it stopped filling, they'd call it the patient died at 10:23 p.m. So this company decided that was bad to have reservoir bags. It was very negative for the patients. Why would you need a reservoir bag unless you were worried they might die? So they had this plastic canister. So when the patient inhaled, they brought air in through this valve into the plastic canister and they breathed out whatever gas was in the canister. Then while they were resting between breaths, the canister would again get some more gas in it. So that time when they breathed in, they got some of what was in the gas and some room air that was also in the canister. So it was a bad design and it went away. It was suggested at one time, and then Japan, they did have humidifiers attached to these machines because the gas is very, very dry. And they did some research where they cultured the water in these humidifiers and found that they grew some really bad bacteria. So humidifiers are a bad idea. And here's what my office looks like, and I really like this. I have my machine here. My assistant can adjust it if I direct her to do so, which is legal in the state of Washington. Here's the percentage of nitrous. Here's the amount of gas I'm flowing. And here are my hoses that go around the patient's head, never around the chair. You always put it around the back of their head. This is a system where they put the machine over here where the patient couldn't see it, and then they brought hose down through the floor and back up to the chair. By the time you change the concentration of gas here, it might be 10 minutes before it changed the concentration of gas in the tubing. Good idea, didn't work very well. This is an unfair system and it's illegal. They didn't have a regular installation for the gas, so the carpenter built a nice cabinet that the oxygen and the nitrous went in, and here's the machine mounted here. If you weren't using it, you just closed it. Heaven forbid if you ever got a fire in the office, the firemen are in trying to put out the fire and one of these tanks goes off. So that's illegal. They wouldn't let you get by with that today. And the ultimate trip to the dental office is some nitrous oxide and some music through the earphones. So, what if you want CE credit for this program? Some states will allow you to claim credits, but first check with your board. If you need proof that you paid attention while you're watching it, I've got a 10-question quiz. You email me and I will send you the quiz. You take it, send it with a stamped self-addressed envelope and a $30 check, and I will grade the test and send you back a certificate that you passed the test. In fact, I'll send you back the test. And that pretty much does it. If anyone has any questions, I can be emailed at fredq@comcast.net. I thank you for watching this tonight.